German confidence in the early years of the Second World War rested on more than tanks, planes, and sweeping battlefield tactics. Beneath the surface of the Blitzkrieg was a quieter, far more decisive weapon, an encrypted communication system the German High Command believed to be unbreakable. Its design blended mechanical precision with mathematical complexity, and to the officers who used it each day, it was as secure as an iron vault. Messages about troop movements, naval deployments, supply shortages, reinforcements, and attack plans flowed through it with absolute trust. This system, Hitler's prized encryption, gave Germany a sense of informational dominance that shaped every early victory. For the British, who could hear German signals but could not understand a single line, it was as if the war was being fought blindfolded. By 1940, this blindness had consequences across Europe. German commanders coordinated lightning-fast operations with such efficiency that British and French generals frequently realized what had happened only after the results were already in front of them. Communications moved seamlessly between armored divisions and Luftwaffe squadrons, allowing German forces to react faster, pivot harder, and exploit weaknesses before Allied commanders could even identify them. The encryption gave German planners the confidence to take risks, knowing their messages would reach their units without interception or exposure. Britain understood that unless this system could be penetrated, the war would continue to lean heavily in Germany's favour. At Bletchley Park, an estate in Buckinghamshire that had been quietly turned into Britain's code-breaking centre, this challenge shaped the work of thousands. The war's most brilliant mathematicians, linguists, logicians, and mechanical engineers found themselves united under a single mission: to break the German code. They did not yet know whether it was possible. They only knew that it had to be attempted. Every day, German wireless traffic crackled through British listening stations. Operators captured endless streams of coded groups, each one a fragment of the German war machine. But without a key, the messages were meaningless. The encryption system itself relied on a machine whose internal mechanics shifted constantly. Each day at midnight, German operators changed the internal settings: rotor selections, rotor orders, plugboard connections, and starting positions. This created a staggering number of possible combinations, far beyond what any human or conventional analytical method could pass. By some estimates, there were more possible settings than atoms in the observable universe. This was why the Germans were so confident. In their view, the British could spend 1,000 years and never decipher a single day's traffic. Yet what the Germans believed to be an impenetrable wall contained tiny, almost invisible cracks. Exploiting these cracks required patience, methodical reasoning, and a willingness to think mechanically rather than purely intellectually. At Bletchley Park, this burden fell to groups known simply as the Huts, each responsible for different types of traffic. Among them were individuals whose work would become legendary. They built theories, ran calculations by hand, tested assumptions, and waited for patterns to reveal themselves. One of the earliest breakthroughs came not from pure mathematics, but from human predictability. The Germans, despite their technical sophistication, were creatures of habit. Radio operators ended messages with predictable phrases. Weather reports followed standard wording. Some units repeated the same introductory lines day after day. In a system built to resist brute force attack, habitual language became the soft underbelly. By comparing repeated phrases and aligning them with intercepted messages, British analysts began to infer small pieces of the daily settings. But the Germans did not remain static. In February 1942, the German Navy introduced new encryption procedures. This upgrade, often called a new key, dramatically increased the system's complexity. British codebreakers suddenly lost visibility into U-boat communications at the moment they needed them most. Allied ships crossing the Atlantic found themselves stalked by submarines communicating through a code the British could no longer read. Losses mounted. For the men and women of Bletchley Park, The new naval system represented not merely a setback, but a potential strategic disaster. To regain access, the British needed a new approach, something faster than human calculation, something capable of analysing the machine's logic at far greater speed. The development of electromechanical devices became essential. These machines, built with whirring drums, electrical circuits, and rotational components, simulated the internal behavior of German encryption. Instead of trying every possible setting, these devices tested only those settings that followed real-world clues supplied by intercepted traffic. The machines were not solving the entire problem. They were narrowing the field, providing candidates, and reducing the impossible to the manageable. Still, even with these devices, progress often felt agonizingly slow. The codebreakers faced days of silence, followed by sudden, exhilarating moments when a machine's indicators aligned and a possible solution emerged. Much of the work involved eliminating false positives and confirming whether a promising lead truly matched the day's settings. Every time they succeeded, the doors of the German command system opened, even if only briefly. The decisive breakthrough came through a combination of mechanical innovation, human insight, and a rare stroke of fortune. In early 1942, British forces captured valuable codebooks from a German vessel destroyed in the North Atlantic. These books contained procedural information, not enough to hand Britain the key, but enough to reduce the number of blind guesses. Simultaneously, the electromechanical devices designed to search through logical combinations became more refined and reliable. Mathematicians at Bletchley Park used these tools to test hypotheses rooted in linguistic patterns and operator habits. The moment the British finally cracked Hitler's new encryption did not arrive with fanfare. There was no announcement. Instead, it appeared as a quiet discovery, a set of rotor positions, plugboard settings, and logical deductions that suddenly turned a meaningless sequence of characters into clear German sentences. The first readable message was mundane, routine orders concerning patrol patterns, but the significance was enormous. The British had regained the ability to read encrypted German naval traffic, a feat German commanders believed was impossible. Once inside, the British discovered a torrent of information. Messages revealed U-boat locations, supply status, operational intentions, and even morale among submarine crews. For the first time in months, Allied convoys could adjust their routes in real time, steering away from submarine wolf packs lurking beneath the Atlantic waves. Ships that might otherwise have been lost now passed safely through dangerous regions. The effect was immediate. U-boat kills declined, Allied shipping losses shrank, and the strategic balance slowly shifted. But the breakthrough did more than protect convoys. It reshaped Allied planning across every theatre of the war. German messages exposed weaknesses in supply chains, revealed overextended divisions, and provided clues to the timing of future offensives. The British gained insight into German expectations, what they feared, what they assumed, and where they believed Allied forces would strike. Intelligence officers could now compare intercepted communications to German battlefield behavior, spotting patterns and predicting movements before they occurred. The codebreakers, however, did not have the luxury of celebrating. The German encryption settings still changed every night at midnight. This meant that each day the process had to be repeated. Identify linguistic anchors, feed possibilities into the mechanical devices, analyze the machine outputs, and confirm the correct daily key. The victory was not a one-time achievement, but a continuous race against time. Only by maintaining this pace could the British sustain the intelligence advantage. The work occurred under strict secrecy. Even high-ranking Allied commanders did not always understand how deeply Britain had penetrated German communications. To protect the source, the British sometimes allowed limited losses to occur if intervening would reveal that they were reading German traffic. In some cases, aircraft changed their flight paths to avoid appearing suspiciously well-informed. Ships altered course under the guise of routine navigation. Every action had to be weighed carefully. If the Germans suspected their system had been compromised, they would introduce new encryption, and the process would begin again from zero. Despite these constraints, the flow of intelligence, later codenamed Ultra, played a decisive role in major operations. It helped the Allies understand the scale and direction of German troop movements during the North African campaign. It exposed supply deficits that forced German units to fight without adequate fuel or ammunition. It revealed disputes within German command structures, highlighting disagreements between Hitler and his generals. The insights not only aided battlefield planning, but also sharpened the Allies' understanding of German political dynamics. As the tide of the war turned, the intelligence gained from the cracked encryption became increasingly indispensable. During the Battle of the Atlantic, Ultra provided advance warning of submarine concentrations. In the months leading to the Allied invasion of France, intercepted messages confirmed that German commanders had misjudged the likely landing site, expecting a strike in the Pas-de-Calais rather than Normandy. This miscalculation, reinforced by deliberate Allied deception, played a crucial role in the success of the landings. Although Ultra was not the sole reason for Allied victories, historians widely agree that it shortened the war, saved thousands of lives, and prevented the Germans from mounting effective countermeasures. The German High Command never fully grasped how deeply their communications had been compromised. They occasionally suspected espionage, but dismissed the possibility that British codebreakers could pierce the encryption. Even as Germany began to lose the war on multiple fronts, the commanders continued to trust their system. They believed that if they were failing, it was due to material shortages, stretched resources, or strategic overreach, not because their encrypted communications were being read almost daily by their enemies. Inside Bletchley Park, the pressure never eased. The workload increased as more German units entered the conflict. New variants of the encryption system appeared, requiring fresh analysis and adaptation. Codebreakers worked in rotating shifts, often through the night, in rooms cluttered with paper strips, machine parts, and chalkboards covered in logical diagrams. Many of the workers had no idea how important their contribution was. They were told only to complete their assigned tasks and leave the interpretation to higher sections. The constant strain produced quiet moments of triumph. When the correct settings were identified, the first translated messages often spread through the room in a hush. There was satisfaction, certainly, but also a renewed sense of responsibility. Breaking the code meant gaining a glimpse into the enemy's intentions, and every decoded message carried the weight of real lives. Convoy crews, infantry units, pilots, and civilians caught in the path of the war. The breakthrough also marked a turning point in the relationship between intelligence and warfare. Before this moment, military leaders viewed intelligence primarily as a supplement to physical force. Yet the ability to read encrypted communications demonstrated that information itself could shape battles as powerfully as artillery or aircraft. Britain's ability to see into the German command system created opportunities, influenced decisions, and prevented disasters that might otherwise have changed the war's trajectory. The long-term significance of cracking Hitler's encryption extended beyond the war. The techniques developed at Bletchley Park laid the foundations for modern computing. The electromechanical devices used to analyze rotor positions represented early steps toward machine computing, and the mathematical theories applied to the encryption anticipated later advances in computer science, cryptography, and information theory. The individuals involved seldom received recognition during their lifetimes due to secrecy, but their work helped shape the technological landscape of the modern world. Yet at the heart of the story is a simpler truth. Germany believed its encryption to be unbreakable, and this belief contributed to its early confidence and sweeping victories. When British intelligence finally cracked the system, the advantage shifted. The Allies gained clarity where Germany assumed opacity, they gained foresight where Germany believed in secrecy. And through this clarity, they were able to navigate the war with a degree of strategic understanding that Germany never suspected. The day British intelligence cracked Hitler's new encryption was not marked by a single dramatic event. It did not involve a storming of enemy lines or a climactic battle. It was instead a quiet analytical triumph achieved in a room full of machines and paper. But its impact rippled across every front of the war, from the Atlantic to North Africa, from the skies of Europe to the headquarters of Allied commanders. The information unlocked by that breakthrough shaped decisions, prevented disasters, and helped bring an end to one of the most devastating conflicts in human history. In the decades since the war, historians have calculated that the intelligence gained from reading German communications shortened the conflict by as much as 2 years. Without it, the Battle of the Atlantic might have strangled Britain into submission. German armoured thrusts could have landed harder and deeper. Allied offensives might have stalled under surprise counterattacks. The ability to read the code did not guarantee victory, but it prevented defeat long enough for Allied strength to reach its full force. What began as a desperate struggle against an enemy's invisible advantage became one of the most significant turning points of the war. In the measured, meticulous work of the codebreakers and in the hum of the electromechanical devices that filled Bletchley Park, the foundation for Allied victory was laid, and on the day the code was finally cracked, the course of the conflict subtly and irrevocably changed.